We interrupt your day with breaking news from the farthest reaches of the cosmos, a story so profound it's shaking the scientific world to its core. For the first time, observatories have detected a signal that traveled for over 1 billion years to reach us. A whisper from a cataclysmic event that changes everything. A massive black hole collision, an event of unimaginable power, has sent ripples through the fabric of space-time. These are gravitational waves, and their capture confirms what Albert Einstein predicted a century ago. It's a discovery Stephen Hawking later built upon with his own groundbreaking theories on black hole mechanics, making this a monumental day for physics. From NASA to the European Space Agency, the announcement is making headlines across the globe, sending shock waves of excitement through the scientific community. This is a stunning vindication, proving the elegant mathematics of these two great minds weren't just theory. They are the literal laws governing the most extreme environments in our universe. So, how did we achieve this monumental feat? And what does it mean for the future of technology and space exploration? Stay tuned as we dive deep into the science and history behind this incredible story. Welcome to New News, where science meets sensation. I'm your host, and tonight we're embarking on a journey to the edge of human understanding to unpack this incredible scientific breakthrough. It began with a whisper from the deep cosmos, a signal that had traveled for 1.3 billion years, finally reaching Earth. Designated GW150914, it was the first direct detection of gravitational waves, confirming a century-old prediction and giving humanity a new sense to perceive the universe. The source was not supermassive, but two stellar mass giants. Locked in a gravitational death spiral, they circled each other at nearly half the speed of light before merging in a final, violent instant, forging a single larger black hole. This cataclysmic merger didn't just happen in space, it fundamentally warped the four-dimensional fabric of space-time itself. As Albert Einstein's theory of general relativity described, accelerating massive objects create ripples in this fabric that propagate outwards at the speed of light. This event was the perfect confirmation. Capturing this signal required the Laser Interferometer Gravitational Wave Observatory, or LIGO, one of the most sensitive instruments ever built. It measures distortions in space-time thousands of times smaller than an atomic nucleus. The chirp signal was so clean and perfectly matched theoretical models that the team spent months verifying it before announcing their world-changing discovery. While Einstein's theory predicted the waves, he was skeptical they could ever be measured. It took generations of physicists to prove him wrong. Later, Stephen Hawking's work on black hole mechanics provided crucial theorems about how black holes behave during a merger, predictions that were stunningly confirmed by the 2015 signal. The power unleashed is almost incomprehensible. In that final fraction of a second, the merger converted the mass of 3 entire suns directly into gravitational energy, outshining every star in the observable universe combined. And this happened 1.3 billion light-years away. When the wave began its journey, the most complex life on Earth was simple algae. For all that time it expanded outwards, weakening as it traveled, until it finally washed over our planet, a barely perceptible tremor in space-time. This discovery ushers in the era of multi-messenger astronomy. For centuries, we have only been able to the universe through light, but many events, like black hole mergers, are completely dark. Gravitational waves give us a new sense, the ability to the universe's hidden symphony, probing the unseen and testing the limits of physics in the most extreme environments imaginable. This achievement wasn't the work of a single person, but a global effort by thousands of scientists in the LIGO and Virgo collaborations. And this is only the beginning. Future ground-based observatories like the Einstein telescope and space-based antennas like LISA will open new windows on the cosmos. They promise to reveal the universe's deepest secrets, perhaps even detecting the primordial gravitational waves from the Big Bang itself. To truly grasp this achievement, let's dive deeper. The first direct detection of gravitational waves, event GW150914, wasn't just a confirmation of theory, it was the moment humanity gained a new sense to hear the cosmos, validating the life's work of two scientific giants. It began in 1915 with Albert Einstein's theory of general relativity, which described gravity as a curvature of space-time. He predicted that massive, accelerating objects would create ripples in this fabric, gravitational waves, but the effect was so minuscule, Einstein himself doubted we could ever build an instrument sensitive enough to detect them. Decades later, Stephen Hawking provided another crucial piece. His area theorem predicted that the surface area of a black hole's event horizon could never decrease. The signal from GW 150914, showing two black holes merging to form a larger one, perfectly matched the predictions of his theorem, a stunning confirmation. Detecting this required the Laser Interferometer Gravitational Wave Observatory, or LIGO. A laser is split down two 4-kilometer-long arms. A passing gravitational wave infinitesimally stretches one arm while squeezing the other, causing the lasers to fall out of sync. The sensitivity is staggering, measuring a distortion thousands of times smaller than a proton. The power of the event is almost incomprehensible. In a fraction of a second, mass equivalent to 3 suns was converted into pure gravitational energy. For that brief moment, this single collision radiated more power than all the stars in the observable universe combined, the most energetic event humanity has ever witnessed. This detection gave birth to gravitational wave astronomy, allowing us to study the universe's dark side. It also ushered in the era of multi-messenger astronomy. Now scientists combine gravitational wave data with light and other signals to create a complete picture of cosmic cataclysms like colliding neutron stars. The ripple effects extend beyond astrophysics. The ultra-stable lasers and pristine vacuum systems developed for LIGO are already finding applications in materials science and metrology. We can now listen to the universe's most violent events completely invisible to our eyes, fundamentally changing our understanding of the cosmos. And this is just the beginning. Scientists are planning space-based detectors like the Laser Interferometer Space Antenna, or LISA. Free from Earth's seismic noise and with arms millions of kilometers long, it will detect the mergers of supermassive black holes and perhaps even echoes from the Big Bang itself. This new window on the universe has ignited a fire in the scientific community. A new generation of physicists and astronomers now has a tangible frontier to explore. Entire careers are being built on tackling fundamental questions with tools once considered science fiction. Ultimately, this discovery is a profound reminder of our connection to the cosmos. These waves are cosmic messengers, carrying the story of their violent birth across billions of years. By learning to interpret their message, we are physically feeling the echoes of cosmic history wash over our planet. Now I want to hear from you in the comments below. What do you think about this incredible discovery that confirms Einstein and Hawking's predictions? Do you believe this will lead to new technologies that could change our daily lives? How do you think gravitational wave astronomy will shape our understanding of the universe? Share your thoughts, theories, and questions in the comments section. If this incredible scientific breakthrough amazed you as much as it amazed me, please hit that like button. Don't forget to subscribe and ring that notification bell for more mind-blowing science news. Comment below with your thoughts on this historic discovery. This has been New News, bringing you the latest in science and discovery. Thank you for watching this video, and remember, the universe is full of incredible surprises waiting to be discovered.